All right. So I forgot. I wrote a note to myself and I forgot to mention what it meant. You guys all did wonderful on your presentations. So again, thank you for that. But on the peer evaluations, a lot of you forgot to evaluate yourself. And so I wrote a note to you. So if you didn't get an 8 out of 8, there were 2 things wrong. And so you can evaluate yourself. You just have to tell me what you did that you're proud of. And then something you could improve on. And so you can just go in, it lets you submit again and just type it in the text box that's there. You don't have to like upload it. And then there were a lot of people who forgot to do that. The other thing is some of you did not do suggestions for improvements. You only said what the people did that was good. So if you want to get all of your points back, you can do that, or you can be like, oh, no, I'm happy with the score you gave me. So I just wanted to mention that. I wrote a note to every single one of you who did that. If you got an 8 out of 8, you were fine. So you don't have to worry about that. And again, thank you. You all got your presentations uploaded. So that was really fun. All right. So we are doing boiling point. And this one, it's the decanol. The key on these is also the explanation. And the reason is they both are alcohols. So it's not the H bonding because they both can H bond. So this is the more carbons. So more carbons, you're looking first for the H bond. If they both H bond, then you're looking at the carbons. The H bond makes a bigger difference. All right, on the second one, it is the pentanol, and it is that it H bonds. All you have to say. And then on the third one, which one do you think it is? I would go with the diol because 2 H bonds. More H bonds is always better. All right, and then now we're going to look at water solubility. So you and I are mostly water-based. The planet is. So if they both have an OH, you are picking the smaller one. So fewer carbons. So be careful. With boiling point, you want the more carbons. With water solubility, you want fewer carbons. All right, on the next one, it is the pentanol and the pentane diol because it does H bond. The pentane is nonpolar, so you can say it's nonpolar or it's hydrophobic. And then in the second one, you have 2 H bonds. So the pentanol, right, yeah. Right. All right, and then any idea about the 1-butanol versus the 2-butanol? There is one that is definitely more water soluble, and why? So if you want that bonus point, I'll add it to next week's worksheet. Which one and why would be more water soluble? You have nothing to lose. I don't take a point away. Anybody? Nobody?
Is it 1-butanol because there's less carbons?
They both have 4 carbons. So bute, they both have 4 carbons. It is actually the T-butanol because it has smaller surface area. So if you draw them, they both have 4 carbons. 1-butanol, our OH is sticking off here, and then we have our 4 carbons. In the T-butanol, our carbons are compacted. So the area, the surface area of the carbons is much smaller than the surface area of the carbons in the 1-butanol. So surface area is a big factor in water solubility. All right, distinguishing an alcohol. This is what we just did on the previous page. So tertiaries, you do the Lucas reagent. And primaries and secondaries, because it immediately reacts. So it turns immediate cloudy. secondaries with Lucas will take about, it will take about 5 minutes with heat. And primary takes a long time. So that's the easiest way to distinguish a primary, secondary, and tertiary is with Lucas. Primaries and secondaries, just a reminder, because this will come up again, they do both oxidize. And so an oxidation is a color change. It is really obvious test. However, both primaries and secondaries oxidize, so you can distinguish, you can't distinguish them from each other with that. You could with the Lucas reagent. There was a third test, and that is dehydration. Dehydration has no visual change. It looks like a liquid. It still looks like a liquid. There's no color change. There's no cloudiness. So you can't do that test. If something reacts, but you don't see a visual change, it won't be a distinguishing feature for it. So we're going to see this, especially next week, as we get into all the other ones, that this becomes a thing that we do. Oxidation is really an easy test to do. But if you have a primary and secondary alcohol, it won't distinguish those two. But if you only had one of them, it's a great way of telling you have that one. All right. There's no questions. I'm going to move on. So reactions. All right. So I plagiarized this page, other than my words on there. And this is another way of saying the Lucas test. So this is where my students said this is the Leroy test. Leroy, it's similar to Lucas. You can call it whatever you want. I have no idea. I'm not that savvy on the test with halogens. Halogens are always reactive. So you see the chlorine, it's going to be a switcheroo reaction. So we're going to have 3 carbons. The carbons on any of these reactions, the carbons do not change. It is always the OH. And so the chlorine goes on. And then you get plus H2O. So the OH, there must have been an H in there, maybe not. But a chlorine comes on. I don't know why he wrote it that way. All right. Next one, H2SO4. The H2SO4 means we're going to dehydrate. So it's kind of nice to write yourself a note. Dehydrate means you still draw the pentagon. You still draw the methyl. You can draw the methyl or you can just draw a line. I like to put a star where my OH was. Dehydrate means you lose water. This is where you're going to make a double bond. So dehydrate means you go to the carbon double bond. This is where you get 2 answers. Does anybody see the other answer? Well, you still have a pentagon. You still have the methyl there. My star's still there. The double bond could have gone the other way. So that's a double bond. So the double bond, again, my star is where my OH was. The double bond can go either direction from it. So here's the question. Which one is the major and why? Because one of them is always a preference. You do show both for full credit, and then you have to tell me which one's the preferred.
The one that's towards the CH3?
Yes. So the top one, that how I drew it, is my major one, because you're moving towards a more complicated place. All right. This is oxidation. So on C, we're going to do oxidation, which means we make a carbon-oxygen double bond. So we're losing hydrogens. So you do your carbons the same. And again, you can do zigzags. This is, now, if you do write the carbons in and you go, okay, I'm going to go to a double bonded oxygen, what is wrong with my answer?
There's too many hydrogens on, or too many bonds on that one carbon.
Yeah, so you lose hydrogens. Oxidation means you lose hydrogens. So if you're going to show your carbons, you got to make sure you lose the hydrogen. Is that Caitlin?
Yeah.
Okay. So yeah, that had too many bonds, so just make sure. If you do zigzags, it's not as hard because you don't have to worry about it. All right. So again, A is Lucas or Leroy. So we're doing the exchange. You can think of it like that. So the OH is going to change places with the chlorine. So you keep your pentagon, you keep your methyl, and the OH becomes a chlorine. You can draw it in a different color if that helps you. And plus H2O. You don't have to show me the plus H2O. I'm showing it because it helps some students. The problem with this one is it's hard to see where the H came from because it's not there. So you can leave off the H2O. All right. Good. This is H2SO4 is dehydrate. So we're going to get the carbon-carbon double bond. And we only get one answer. So you can show your carbons. This is again where my OH was, so I can only make a double bond one way. Or you can show zigzags. We get one butene. If you show your carbons, you lose this OH and this H. So there's your cowgirl chemistry. People go on these fancy dancy science conferences to learn cowgirl chemistry, and I found it really funny, and so I usually get giggles teaching it. All right, and then the last one on this is oxidation. So when you do the study set, right, I'll open next week's folder. There'll be study set and worksheet for Monday, and then notes. And then for Wednesday, there'll be the study set and worksheet from the notes that we do on Monday, and then another set of notes. All right, so we have 5 carbons. You can do zigzags, and the middle carbon becomes an O. So this is a ketone. This would be just for naming, a prelude to what we're getting to next week. Pentanone. One is the double bonded O. You do need to number. So you have to tell me it's at number 3 this time. On the ones on the other page, I did not, because there was only one place it could be. You can ponder that. We'll talk about ketones next Wednesday, so we'll worry about it then. All right. You can make a sketch. There's our 2-butanol. It's a puzzling question. We're dealing with alcohols. How do I make an alcohol? Anybody? It's a great question. Somebody who's not on the board? This is on your celebration. I'll give you a hint. It's the opposite of a reaction we did up there. Caitlin, you can answer if you want. You just don't get your name up twice. So I always tell people if your name's already up there, you have to like sing the alphabet song. That would be a good one for in here.
You hydrate?
Yes. So what am I going to start with? That was Christy.
You're going to start with H2O.
H2O is going to be one of them. You are adding H2O. What I want to know is, what are you adding the H2O to? What is the organic compound?
Going to be 2-butene.
Yes. So 2-butene. And there's actually one more piece. I'm making her work hard. There does have to be something on the arrow. Do you remember what goes on the arrow?
H2SO4.
Yes. Wow. So either she's got an amazing memory, which is good for all of us, or she has really good notes and really handy notes. And so learning to take really good notes, which is going back and just watching the videos. You can fast forward. It is actually the same catalyst that is used for dehydrating. So this is hydration. So we're going to hydrate. This reaction goes both ways. It actually, the double bond is much more reactive. And so how can we make it go backwards? Well, we heat it. And so what the heat is actually doing is it's burning off the water. So the water can't react. It's basically boiling off the water and getting rid of it. So even though we're showing the water there, it's going to come out. It's going to be so hot from the heat that, right, this is over the boiling point of water, that the water is going to disappear into the great blue yonder. So yeah, great job, Christy. All right, the next one, pentanone. Which 2-pentanone just means our double bonded O is there. So we would want to start with 2-pentanol. And you do have to show something on the arrow. So I'll just make a bigger arrow. And this is oxidation. So we're going to lose hydrogens. So you can write the word. I'm writing the words because some students, the words actually work better than the pictures, and some students, the pictures speak 1,000, a million, a billion, and Avogadro's number of words. All right, and then cyclohexene. So wherever the double bond is, the methyl is there, and so this is dehydrate. So we'd start, the key when you're doing these reactions, we want to start, the carbons are the same, what's changing is the double bond or something. So to make a double bond, we want to put an OH. There are different ways you could do this. The best place to put the OH, I would think, would be here. Because if it fell to the left or the right, you get the same answer. You can ponder it. It would also fall outward, but that would be a much more minor. If we put it here, I would also give you the credit. You do have to tell me H2SO4, and you do have to tell me the heat symbol. So questions with any of those, or you ask me the questions on Monday. Everybody's tired because it's Wednesday, and it's been a rainy week. And let's go ahead and do the last page. And it's almost 8 o'clock at night. Everybody's eating. Nobody's there. It's the naming. These are actually, yeah, we can do it. So there's one, do pink. There's my OH. The OH does not have to be at 1, but it is here. So 1, 2, 3. That's a side group. That's a side group. And this is where the color is really nice. 4, 5. So when I get to 5, either direction, so this is telling me up here that there are 3 CH3s around this carbon. So those parentheses, they're the hardest thing for students, and some people just never get them, and it's not that really that big a deal. Which way do I go and why? There is only one right way. Do I go up or do I keep going to the right? Do I keep going in a line or do I go up at this point? Because either way, you get 2. You get to 1 heptanol no matter what. you're going to go up because you want to go the way where you get smaller side groups. So we want to break it up as much as possible. This one I circled in blue is my ethyl. So this one's a crazy name. This is a 5-ethyl. And again, this is why the colors are really amazing. They're like a game changer. So if you didn't get colors, go and get some colors, colored pencils you can erase, or these friction pens. So 2, 3, and then 6, 6. So you do have to number them twice. The numbering starts at the end closest to the OH. So 4 is tetramethyl. All right, one more piece with this one, we have to classify it is a primary. And so that's what this one is. This one was a tough one. If you got it, that's awesome. If you didn't, you can go and ponder it. All right, the next one. This is where I was saying earlier, my OH unfortunately is at number 1 on both of these. It is not always at number 1. These are tough examples, but we're going to keep them. All right, this is saying again, there's 2 CH3s, but they can't be in a row just because of how, so one of them will stick up above here. So that's why I crossed off there. Here, same thing. One is there, and then the other one I'm going to stick up here. So that's how you can get rid of the parentheses. And then 5, I'm pretty sure I can get to 6. 3, 4, 5, 6. Yeah. So 3, 4, 5, 6. And then I have a whole bunch of side groups. So these are methyls. And then the blue one, that guy's an isopropyl, and the, I don't know if you can tell that's orange. What's that orange one that I just circled? The blue one up here is an isopropyl. Well, that's not orange. It's probably why you're confused. That is isobutyl. This is, it's good to have a challenging one. And yeah, you can ponder that when you're more awake and feel rested. So it is a 1-hexanol. It is a primary again. And then we have all these side groups. So isobutyl does come before isopropyl. So we have a 2-isobutyl. And then we put a dash. And then we have a 3-isopropyl. And then we have methyls at 2 and 4. So a 2,4-dimethyl. And then a 1-hexanol, and it is a primary alcohol. So that's quite the mouth load. So 2-isobutyl, 3-isopropyl, 2,4-dimethyl, 1-hexanol. All right. So the last one. This is a side group. When a benzene ring is a side group, this is called phenyl, P-H-E-N-Y-L. And then we number. And it is, this could be number 1 or this could be number 1. I picked that as number 1 because it makes my OHs have smaller numbers. So again, unfortunately, a lot of my examples today, the alcohol is at 1. It does not have to be at number 1 though. All right, so there's my chain, and we also have this CH3 down here, which is a methyl. So the methyl is going to come first in the name, so 2-methyl, and then 1-phenyl. And then the main part, we're going to name as a 1,2 butanediol or butane glycol. I'm going to go with the diol name. So the di is because we have two OHs. And we're going to classify those OHs. So these were actually tough ones. The practice could have been your worksheet next week, but I decided we do it as practice today. That at number 2, that is a tertiary. So this carbon at number 2 is attached to 3 carbons. Immediately next to it, it is surrounded by 3 carbons. That's why it's a tertiary. This guy here at number 1 is a secondary. And that is because it has this phenyl side group there. So this carbon here, it's not the OH, it's the carbon the OH is attached to. If it's a monkey in the middle, it's going to be a secondary. If it's a monkey in the middle of 3 things, it's a tertiary. And if it's sticking off the carbon, it really has to do with how many hydrogens the carbon has attached. So on a primary, the carbon will have 2 hydrogens, on secondary 1, and tertiary none. You can ponder that. All right. So 3-pentanol, you can do zigzags. If your 3 is pointing down, well, it doesn't matter. We're going to also have an isopropyl. So isopropyl looks like that. On the next one, cyclohexanol, we do our circle. Wherever you put your OH is number 1. And then at 1, and then at 4, we have a methyl. So that's my 1, 2, 3, 4. Keep counting. All right. And then pentenol. So what's going on here is we have a double bond. The double bond is at number 1, and the alcohol is at number 3. So we don't have to worry about cis trans, so we'll just do zigzags. So from 1, 2, I put a double bond. At number 3, I put my OH. And at number 3, apparently I'm doing an isopropyl again. I must have liked isopropyls when I made this up. I don't know why, but that's what it looks like. But it has this. This is our ene right there. All right, and then we just have a couple reactions. Are there questions? I'm kind of getting the sense that people are tired. People are even there, so I'm just keeping going. Again, this symbol here means heat. This first one is a dehydrate. So I'm going to put my reaction over here. 2-butanol, did this one. And H2SO4. So you're going to go, dehydrate means we get the double bond between the carbons. This is where we get 2 answers. So my OH was here. I also could have put my double bond that way. Towards the middle is the major. So my top way is the major. The other one's the minor. So like the coal miner, right? But spelled different. All right. Sorry, I find myself funny. Oxidation. It's so fun with Zoom because everybody's muted. So you have to make your own jokes and laugh at them. So 1-butanol, for the fun of it, we'll put the OH at this end now. And we're going to oxidize. So oxidation, we get a double bonded O. We're going to lose just hydrogen. Whereas in the dehydration, we lose water. You can show the plus water if that helps you. A lot of students, that helps them. You can show on the oxidation plus hydrogen. It's not quite right, but you don't lose the oxygen. So you're going to keep the double bond, and this is butanol. So double bond O is at number 1. Christy, did you have a question, or is your light, you just lit up?
No, I don't have a question. It just lit up apparently.
Okay. And you're the winner. This is another oxidation. So that just means oxidize. Something I always say is the H2SO4 is the one that is different, and the ones with the chlorine are different. So all the other ones are oxidizing. And again, you can always ask me to double check. I usually do the generic O like that. So you can, if you want, you can say plus hydrogen if that helps you. That's not actually what happens, but if that helps you, you keep the oxygen, you just lose hydrogens. And so this is cyclopentanone. Vincent, you're really quiet today. Maybe because your internet's not great when you're, okay. We got one more, almost done. So 2-methyl, 2-pentanol. It doesn't matter to me if you show the OH above or below. So we're going to, this is the exchange. So we're going to swap the OH and the chlorine. So we're going to get, the methyl stays on there, and where the chlorine, where the OH was, we put the chlorine and we get plus H2O. So the chlorine there just goes on there. The OH comes off. And that's it. That's Lucas. I don't know why I spelled it like that. Is there any questions? All right. I'm going to stop, and you can remember to finish your peer reviews if you did.